Okay. So this is a follow-up to my last video where I'm going to show you why we know that work is negative change in potential. Okay. So remember before that we had from our definition of work that it's the integral from A to B of f dot dl along some path. Where we've got some path that defines our L, and we start at a point A and end up at a point B. Okay. And we're going to assume that for every point in that path, we can write that path L as a function of t. So there's some function L of t that defines the path, right? And then our velocity is the derivative of that path, okay? All right, so that means that we can write our work like this. The integral from TA to TB, f dot v dt, okay? Just like we did in the derivation of the work energy principle. And now we're going to calculate this dot product, right? And we'll just use rectangular coordinates for that. So our f is fx I hat plus fy j hat plus fz k hat. And our v is vx I hat plus vy j hat plus vz k hat, right? And that means that we can write our work as the integral TA to TB, fx vx plus fy vy plus fz vc dt, okay? Now, we are going to define some function u as a function of x, y, and z. And we want to think about how that function u changes with time along that path, okay? In other words, we want to find du dt, okay? Now, we can write du dt due to the chain rule as the partial derivative with respect to x times dx dt plus the partial derivative of u with respect to y times dy dt plus the partial derivative of u with respect to z times dz dt. Right? This is just the chain rule from calculus, okay? And now we should notice that dx dt is vx, dy dt is vy, dz dt is vc, okay? And so that means that we can write du dt like this, du dx vx plus du dy vy plus du dz vz, okay? Now, let's compare this thing we just wrote to our integrand up here, okay? And hopefully you notice that if fx is negative du dx and fy is negative partial u partial y and fz is negative partial u partial z, then we could write that whole thing up above, right, as the work now is equal to negative integral from TA to TB du dt. dt, right? Because the right side of my second yellow equation is equal to du dt. So I've just plugged that in for f dot v. Okay. And then that's just another way of writing integral from ua to ub du, which would be negative u b minus ua, which is negative delta u is the work. Okay, so this shows us that the work done by a conservative force is negative change in potential energy due to that force. All right.